Hello and welcome to my Algebra 1 review series. This video covers Chapter 9, Section 8, titled Factoring by Grouping. By the end of this video, you will have reviewed past lessons describing the methods of factoring polynomials with 4 terms and factoring trinomials by grouping. You will use your new skills to find the dimensions of a rectangular prism. If you'd like me to cover any of these topics in greater detail, please leave a request in the bottom in the comment section below. Please subscribe to my channel if you find this video to be helpful. Thank you. Okay, so let's start this review off with a definition. It says factor by grouping. You can use the distributive property to factor by grouping if two groups of terms have the same factor. So we're going to see that. What does that mean, two groups have the same factor? It'll be obvious as we move through, and they're pretty easy to find, but it's very powerful. Okay, objective 1, factoring polynomials with 4 terms. You can use the distributive property to factor by grouping if two groups of terms have the same factors. So let's look at these. What do we have in front of us right now? First of all, we're going to see 4 terms. So y cubed, right here is one term, y cubed, 3y squared, 4y, and 12. And did you see how the exponents came down as we went from left to right? Okay, and it's kind of, you order them this way when you're gonna do this factoring by grouping. So now that we've done that, what can we, in the first group, we're going to call the first two one group, and the second two a different group. So what can you factor out of the first group that's common to both members or both terms in that group? Well, if you look, we have a y term that's a y cubed and a y squared. So that would imply then both of these terms have at least a y squared in them. And so we do that. We pull out the y squared. And when we do that, using the distributive property, we see that we have a y plus 3 remaining. Because we took a y squared out of y cubed, and we have a y. We took a y squared out of a 3y squared and ended up with 3. And here's the y plus 3. Now we do the second group. And this is where it gets interesting, because now we're going to pull a factor out of here that's common to both. And we'll see where we end up. So if we take the 4 out of here, there's no y in both. There's only constants that are common. So we have a 4 and a 12. So if we pull a 4 out of both of these terms using the distributive property, we'll have 4 times the quantity y plus 3. Oh, look at this. We have a y plus 3 here and a y plus 3 there. Well, now using the distributive property once more, we can take and pull out this y plus 3 out of both terms. And when we do that, we'll get the first term, which is y squared. Right here, we're going to put parentheses right here. We're going to make our front term, or the first term. We have this y squared when we pull out the y plus 3, and we have a 4 when we pull out the y plus 3. So those, using the distributive property, we're going to have y squared plus 4, here's the y squared and here's the plus 4, times the factor we pulled out, the y plus 3 and the y plus 3. So they come out, and what you're left with is the y and the plus 4. And so that makes a term, y squared plus 4 and y plus 3. That's it. We factored this now, using grouping, and we used the distributive property twice. So to factor by grouping, look for common binomial factors of the two pairs of terms. So we're looking for the common binomial factors. That's what as you look at these terms, can I see something common? You have to use a little mental math generally to do it, but that's what we're doing here. Okay, example 1, factoring a 4-term polynomial. We're going to do the same thing we just did. First of all, you're going to see that we have we've taken this number now, which is 4n cubed plus 8n squared minus 5n minus 10. And you're going to see that we're going to basically break it up into 2 groups. They're not multiplied, by the way. They're just 2 groups. In fact, I'm pulling them together. And you're going to see it here. So this will be a group, and this will be a group. And when we do that, we're going to look at the first pair, the 4n cubed and the 8n squared, and what's common. Well, we see that there's the highest number of n's is 2n. N squared is in common in both, and we can pull a 4 out of both terms. So if we do that, we're going to pull out a 4n squared, which is the 4 and then we're going to be left with what? An n and a plus 2. Because when you take 4n squared times n, you're going to get 4n cubed. And 4n squared times 2, you're going to get 8n squared. And now we'll do to the second set of terms here. And what do we get then? We're going to take and we're going to pull out of the second terms the negative 10 and the negative 5n. We're going to take these terms here and we're going to pull a 5 out. We can pull a 5 out of here. We can't get an n out of both, but we can get a 5 out of both. So we do it. We pull a negative 5 out because it's negative 5, negative 10. We're pulling the negative 5 out, and that'll make the term positive inside the parentheses. And then we have the n plus 2. Well, because negative 5n and negative 5 times 2 is 10, right? Negative 10 or negative 5n. So you see the two terms. But when we separate it, we have this n plus 2, n plus 2. And that's right here. That's the term we're trying to pull out by grouping. We grouped them, and now we're factoring them. We've taken out the common factor using the distributive property again here. And what's left over, when you pull a 2n plus a 2 plus n plus 2 out of this group here, you have the 4n squared left. And when you pull out the n plus 2 term out of this pattern here, you have the negative, you have the negative 5 right there. And then the other factor is going to be the n plus 2. So as you see it, we pulled the n plus 2 out and we're left with 4n squared minus 5. And then check it. It says they wanted us to check this. So let's do it. So here's where we started. So is that equal to 4n squared minus 5 times n plus 2? Well, let's take a look. 4n cubed comes from 4n squared times n. We have a plus an 8n squared by what? We take 4n squared times 2. That's right there, 8n squared. And then we take the 5n, negative 5n. We have negative 5n. That's negative 5 times n. And then we have the negative 5 times 2 is negative 10. So yes, this checks to be correct. Okay, example 1, check your understanding. So hopefully you'll stop the video and just try these two on your own. Factor each expression and then check your answers. So why don't you go ahead and do that. And when you come back, then we'll go ahead and take a look at the solution to these problems. Okay, now that you're back, we're going to go ahead and take a look at them. So if we try to solve these, we're going to find out that the first problem was 5t to the 4th power, right here, plus 20t cubed, plus 6t plus 24. And they're grouped already in order because we have from left to right descending powers, which is important because otherwise it wouldn't work if they're just random, and they need to be in standard form. And then when we do that, we're going to see what can we pull out of these terms up here to factor it, okay, to get this ball rolling on that. So the first thing we find out that this term has a 20t cubed, the second term here, and the first term is a 5t to the 4th. Well, that means there's a t cubed in the 5t to the 4th, and the 20 has a 5 in it. So that means we can take out a 5t cubed, because we can get the t cubed out, and we can get a 5 out, and we're left with a t and a plus 4. Okay, and if we do that to the second set of terms here, we're going to end up trying to pull out a 6, because there's no t in both, but there's a 6 in both terms. So we can take out a 6. We can pull the 6 right here. And what are we left with? If you pull the 6 out, we're left with the t plus 4, because 4 times 6 is 24. T plus 4. Well, look at this. T plus 4, t plus 4. So that means we can now factor the t plus 4 out. And when you do that, we factor the t plus 4 out of the first term, and we're left with the 5t cubed. And then when we pull the t plus 4 out of the second term, we're left with the 6, the plus 6. Here's your plus 6. And then there's your first term in here, your first binomial. And then we're just going to multiply it by the term we factored out, which is t plus 4. Here's our second binomial. That's the answer to this. Now to check it, is 5t to the 4, 20t cubed plus 6t plus 24 equal to 5t cubed plus 6 times t plus 4? Well, 5t cubed times t is 5t to the fourth. And then we have 5t cubed times 4 ends up being 20t cubed. And then we take the inner here, 6t, 6 times t is 6 times t, and 6 times 4 is 24. And we write them all down. We look, yes, that is the solution to that problem. Now let's do B. B says we have a 2w cubed, which these should have been, sorry about that, tw cubed and plus w squared, and then it's minus 14w. I put a plus there and put these in parentheses so you could see that it's a plus a negative number and also a plus a negative number, minus 7. But when they wrote it out, it was a 2w cubed plus w squared minus 14w minus 7. Okay, so now we're going to try to pull something out of the first two terms, these two. What can we pull out? Can we pull out a 2? No, because there's not a 2 in both. We can pull out at least 2 w's, though, because there's a w squared here and a w cubed here. So we can pull out a w squared. And what are we left with when we pull that w squared out? We're left with a 2w, okay? And we're left with 1, because we took the w squared out, and we're left with 1. Okay, now we go to the next term. So there's our first term right here, first binomial. So now what can we factor out of negative 14w and negative 7? We can factor out a negative 7. And when we do that, we get a negative 7 times 2w, because negative 7 from 14w is 2w. And negative 7 times 1 is negative 7, so we're left with a 1. So we have w squared minus 7 and 2w plus 1. That's our solution. Now let's see if it works. What we want is this right here, and we want to know if this, what we just came up with, will give us that. So let's do it. W squared times w squared, 2w, times w squared times 2w is 2w cubed. W squared times 1 is w squared. Plus, right? Negative 7 times 2w is negative 14w, and negative 7 times 1 is negative 7. Yes, it checks. Okay. Okay, example 2, factoring completely. So what they're asking you to do here is factor completely means you're going to find it's like a code word, because what it means is not really a code word, but when you hear that, think that there's a term in all 4 of these terms, or as many terms as you have, that's common to all of them. So what they're looking for you to do here is if there is a common monomial in each one of these terms that can be removed, take it out. It'll make factoring your trinomial or whatever's left easier because you've gotten some of the numbers out, so it's not as hard to manipulate. And in this case, I can see where there's a p in every term. Every term has a p. P here, a p here, a p here. So that means you can at least take a p out of every term. Okay? And then there's a even, they're all even numbers. So you can at least take out a 2, okay? And maybe more. I don't know. So let's go on and work the problem and see how it turns out. Okay, for example 2, it says factoring completely. And what they're asking for us to do here is to take out and remove any common factors, monomials, before we start doing our factoring by grouping. So you look here, we have a 12, a 10, a 36, and a 30. I can guarantee right off the top, that there's a 2 that can be pulled out of all of these terms. Can a 4? Well, 30 times 4, no, there's no 30 and 4. 36, yes, we could. 10, we cannot. So there's no 12s. I think the only thing we can get out of here is a 2. I think that's the only thing we can pull out is a 2. Oh, we can pull out a 2p out of the entire. So we have the 12 can take out a 2, the 10 can take a 2, 36 can take a 2, and the 30 can take out a 2. And each one of them have a p in the p term. So we're going to go ahead and rewrite the equation, and we're going to factor out a 2p. So we're going to go down here, and here's our original equation. And we've decided that we can factor out this 2p right here. And when we do that, we have 6p cubed plus 5p squared, okay, negative 18p and negative 15. Okay, and I wrote this in the form where it's plus a negative plus a negative. Okay, so now we carry it on to the next line. Now we've got our groups. We've pulled out the factor ahead of time. We have our groups remaining now that we're going to go ahead and factor by grouping. So we start again with the line. We have a p, a 2p. Now we pull out what's common in our first group right here, in this first group. Well, we have a p squared that's common, but there's nothing common between 6 and 5, except the 1. So we're going to pull out a p squared. And what's left over when we do that? We're left over with the 6p here, and we're left over with, we've taken out the p squared, so all we're left with now is a 5, plus 5. So this is p squared times the quantity 6p plus 5. And now we're going to see what can we take out of the negative 18p and the negative 15. Well, we can take out a negative 3. So when we take out a negative 3, we get a 6p. 6p times negative 3 is negative 18. And we get a 5. 5 times negative 3 is negative 15. So here are two, oh, look at this. This factor and this factor. They're identical, so we can pull them out. That's how we're factoring by grouping, right? We've grouped and now we're factoring using the distributive property. So now we have our 2p that we started with. And we have, when we take the 6p plus 5 away from the p squared, we were left with p squared. And now we have a negative 3. So we're going to get a negative 3 because we're going to take away the 6p plus 5. We're going to factor that away from the negative 3. So now we have p squared minus 3 times p to the 6th plus 5. Here's our entire solution. 2p times the quantity, p squared minus 3 times the quantity, 6p plus 5. Okay, so here we go. Example 2, check your understanding. This comes with the factor completely section example. So, you know, that's like a code word for you're going to pull a monomial out of every one of these terms. So let's try it. So we have 45m to the 4th and 9m cubed and 30m squared and a 6m. What can come out of these? Well, right off the bat, you see that we can pull an m from everybody. So there's at least one m that we can take out right here. And since every one of these also, 9 you can take a 3, 30 you can take a 3, 6 you can take a 3, and 45 you can take a 3. So I'm going to pull out a 3m out of this in the very beginning. So I'm going to pull out a 3m. And then I'm going to see what else now I'm going to go ahead and see what's left. Now that I've got the 3m, I have 45m cubed to the 4th, leaves us 15m what? M cubed minus negative 9. We can pull 2 3's out of 9, or 3 3's out of 9. So we're going to have a negative 3, and we've taken out one of the m's. We're going to have m squared now. Now on the next one, we're going to have a positive. We're going to pull 10 3's out of 30. So we're going to get 10. And we're going to pull 1m out of m squared. We're going to have an m remaining. And finally, we're going to have a negative. We're going to pull 2 3's out of 6. So we can get a 2. And there's no m because we're pulled the m also. So that's all that's left is the m. So here is the this 4-term polynomial that we're going to now factor by grouping. We've already pulled out this one lead monomial, 3m. Now we're going to see if we can get a grouping going here. So using the first 2 terms here and the second 2 terms, we're going to do the first 2 first. What can we take out that's common to both? We have an m squared and an m cubed, so we can get at least an m squared. And a 3, and it comes out of 15, and a 3 is the most we can get out of this one. So we're going to pull out a 3m squared, and that's going to be 3m squared out of both of those, right? So it's going to be times 3 times what is 15? 3 times 5, right? And an m. So it's going to be 5m and negative. And we pulled out a 3m squared. We're left with a negative 1. And then we're going to, out of this one, pull 2 out. Certainly we can pull a 2 out. I shouldn't have put that. I drew that parenthesis too soon. Okay. We're going to pull a 2 out right here. So we're going to get a 2 times. We can have a 2 comes out of 10 5 times. So it's going to be a 5m. And a minus 1 now, because 1, you get 1 2 out of 2. So there we are now. So we have these two terms. Okay. And when we factor this now, we're going to have, we're going to pull out this is a plus here, by the way. So we're going to pull out this 5m minus 1 from each of these terms here. Each of these, and this in the beginning it's 3m squared, and then it's a 2 for the second term. So we're going to have a 3m squared, and we're pulling out this guy. And then when we do that, we're going to have a plus. We're going to be left with a 2 over here, right? 2. And because we're pulling out the 5m. So there you have this term here. And we're going to have a 5m minus 1. Because that's what we separated from it using the distributive property. So it's going to be, and then also there's the 3m in the beginning. Don't forget that. So it's a 3m squared plus 2 times 5m minus 1. There's the solution to that problem. Okay, now in objective 2, it says 2a because there's 2 slides to get this point across. It says factoring trinomials by grouping. So how do we go about doing that? It says you can also factor by grouping to find the factors of a trinomial of the form ax squared plus bx plus c. You may want to use this method when you cannot quickly factor a trinomial using the methods you've learned in 9-6. Okay? You can use these steps to factor the trinomial, such as 48x squared plus 46x plus 5. Seems pretty daunting, and it is unless you kind of have a procedure or a process for determining what you're gonna do. So the first thing we do when we have a problem like this, any trinomial this will work on, it said, any trinomial. But on these big ones, it's especially important. The first thing we're going to do is we're going to find the product of a times c. Here it is right here. Here's the a times c. And what is a times c? The a term is the 48 over here, and the c term is 5. The a and the c. They want us to multiply it. 48 times 5. And when you multiply 48 times 5, we're going to get 240. And this is what we're going to factor to try to get our inner terms. But it's not that hard. We'll take a look at it. So what you start doing is you just start walking them down. When there's a lot of them, you might want to, after you get a little experience with this, you might say, well, I don't need to start at 240 times 1 because that's way out of line with the kind of numbers I'm looking to find here. I'm looking for a 46, and 200 and 201 or 240 and aren't close, right? So you need terms that'll eventually end up summing to 46 is what you want. So, but we're going to go work from, to show you, we're going to work from the very beginning. So the first thing you do is you say, what is 1 times 240? That is the first two factors. And you add them together, and you're going to get 241. Is 241 the number we're looking for? No, we're looking for 46. How about if we do 2 by what? The next term is 2 times 120, because 2 times 120 is 240. And so now is 2 plus 220, is that equal to 46? No. How about 3 times 80? That's 240. Is 3 plus 80? No, that's 83. How about 4 plus 60? That's another set of factors. Nope, that's 64. 4 plus 60. A factor is 5 times 48. If you add those together, do they give you 46? No, they don't. How about 6 times 40? If you add those two together, do you get 46? And bingo, yes you do. There's our factors. We're looking for the 6 and the 40. That's the numbers. So on the next slide, we're going to see step 3, rewriting the trinomial using the sums. We just came up with the sums, okay, which were the 6 and the 40. So when we do that, here we get 48x squared, that's the first same first term, and the 5, so that's what we started with in the 48. What we're looking for, well, it's actually right here, the one we're dealing with right now. We're looking for the inner term. Well, it's 6 plus 40 is 46. 6 plus 46 times x. That's 46x. But that's going to be broken into 48 squared plus 6 plus 40, 6x plus 40x. So we've got the two sets of terms here, plus 5. Okay, so now that we've got that, now we got those inner terms separated. We started off with 6 times 40 is 240, and 6 plus 40 is 46, and 46 was the number we wanted. And so now we stuck that, the 4 plus 6, the sum, in this is the inner term with an x. And then we did use the distributive property to distribute the x to the 6 and the 40. So now we have 6x and 40x. And the entire equation is now a 4-term polynomial, 48x squared plus 6 plus 40x plus 6x plus 40x plus 5. And now we're going to group, factor by grouping. How do we do that? So we're going to say, well, now that we've distributed this way, we're going to say the first one, we're going to say, we're going to group the 48x squared plus the 6x, and then we're going to group the 40x and the 5. Okay? So when we do that, we're going to be able, here is the 6x, can we get a 6 out of 48? Yes. We can certainly get an x out because it's an x squared. So we're going to take a 6 out of the 48. So we're taking out a 6, and we're left with a 48 plus 1, because for 6x divided by 6x, to factor it out, gives us 1. So 8x plus 1. And now we do the same thing on the next term, 40x and a 5. Well, the most we can take is a 5 if we can, because there's no x's or anything else. So we take a 5 out, 40 will give us an 8x. So we take out the 5, and we're left with 8x plus 1. And here is our group that we're looking for. And now when we factor those two out, we're left with the 6x and the plus 5. So we have 6x plus 5 times 8x plus 1. That's it. It's factored. So as you look for factors, here's something to keep it in mind. I think I mentioned it before. As you look for factors of AC that have to sum to B, that's what they're doing. The A and the C factor have to sum. When you multiply them, have to sum to the B term. Okay, excuse me. So when you add them together, so you do not have to list all the possible factors. Use mental math to eliminate those that give you sums that are too great or too small to be reasonable. Like I said, the 1 and 240 aren't getting you anywhere near 46, and the 2 times 1, the 2 and the 120 won't get you anywhere near 46. But as you slide down, we found that 6, the 4s, the 6s, those numbers we're now getting in the range, right? The 6 and the 40, that was 240, but it also 40 and 6 is 46. The one ahead of that could have been usable, maybe the one below it. But you kind of use your mind, just think about some factors before you have to write them all down. That's what they're suggesting here. Okay, example 3, factoring a trinomial using grouping. It's just what we talked about. So let's see how it works out. So they're giving us 24q squared plus 25q minus 25. So we take the A term and the C term, and we multiply them together. When you do that, you get negative 600 right here. Negative 25 times 24 is negative 600. Then look for the factors of 600 that will give you, that'll add together and give you what we're looking for. And what we're looking for is a 25, the B term. So if you pick 12 times 50, we're moving quite a ways through the list already. If you take 12 and 50, because that's going to get us possibly what we're looking for, we're going to take negative 12 and 50 gives us 38. Now, we're looking for what? A 25. How about 15 and 40? A negative 15, by the way, I should have said. Negative 12. Negative 15 and 40. 40 minus 15 is 25. And guess what? we found it. Here are our terms, negative 15 and 40. So now we're going to go down here. We're going to rewrite our equation with our two middle terms. The first one's the 24q squared. The last one's the minus 25 from up here. And the inner ones is a negative 15q plus 40q. Now you can factor them using the distributive law and grouping. So here we're going to pull out of the 24q squared minus 15q, we can pull a 3q out. Because the q we can get out of the 15, and we can get one of the q's out of the 24q squared. So we can get a 3. You can't get a 5 out of 24, and we can't get a 15 out of it. So the only thing else that's left is the 3, and we can get a 3 out of both. So we take out a 3 and a q out of both, right here, and we're left with an 8. 24 divided by 3 is 8, and we've taken out a q, 8q, minus 5, because we started with the 3q, right? So we're left with 5, because we took a 3q out of 15q and ended up with just the 5. So now we have the 8q minus 5. We do the same thing here. Out of 40 and 25, we can take a 5 out of both. We can take a 5 out of the 40 and get 8q, and take a 5 out of the 25, the negative 25, and get negative 5. And lo and behold, we have the negative 8q minus 5 and the 8q minus 5. So when we pull those terms out, what's left is the 3q and the plus 5. Right here, the 3q and the plus 5. And that's times 8q minus 5. Okay? So that's and I could write that over here just so it makes sense, because I have the 3q plus 5. I drew this little box over here. I should have just drawn them out. I hope that makes sense. Okay, example 3, and it's A, because that means there's going to be 2 slides for these 3 problems. Check your understanding. So we're going to factor these trinomials by grouping. Why don't you go ahead and give it a shot? And I can tell you these are tough. They're big numbers, and you got to do a lot of factoring. And when you get back, I'll show you how I factor it, and hopefully we can possibly come up with a solution that might be simpler. But okay, go ahead. And when you get back, we'll continue on. Okay, I think that's enough time. You're back. So let's start off with the very first one. So we have 63d squared, 44d, and 5. We've got to come up and multiply 63 times 5. I'll do that right here. There's not a whole lot of room, but I'll say 63 times 5 ends up being 315. Okay, so now we're going to factor 315 until we can get factors that'll give us 44. Well, I don't know what they are offhand, but I know one thing. I can divide. What can I do? I can divide into 315. I can divide a 3 in there, right? Because a 3, that'll go 315. I'll get it. It'll be what? If I divide a 3, it's going to be 105. So I can take a 3 out, and I'll have 105. Okay? So can I take a 3 out of 105? I think I can, because 3, it's 35, 105 is 90 and 15. So if I can get out a 35 right here. And if I had to go further, I would say right here, I would say 35 is a 5 and a 7. And I'm kind of done. Now I'm at primes all the way down. Okay? But when I go back and I look, I see that I need to have a 44. Well, this right in here is very close to 44, because I got a 35 and a 3. But no, it's not a 35 and 3. It's 35 and 3 times 3. You have to multiply all the terms that have been discarded. That gives us 9 and 35. 9 and 35 is 44. So our terms are going to be 9 and 35. Okay, that's what I'm going to go with on those terms. So now what do we have to do? We have to go over here and write these. So we're going to say 63 d squared plus what? Plus 9, right? D plus 35d plus 5. Okay, so now I can factor these like we do. We take this group here and this group here. So 63, 9 times, well, we can take a 9 out of 63 because it's a 7. 9 times 7. So we can take out a 9 and we can take out a d. So I'm going to take out a 9d, and that's going to be times, if I take the 9d out of 63d squared, I'm going to have 7d, and I'm plus 1 because I took out a 9d. And then on this one here, I'm going to have a plus a, I have a 5, and a 5 can come out of 35 7 times. So 5 times 5 times 7d plus 1. My writing's a little sloppy there. I'm sorry. I was not right. I'm going to erase that and make that 7d a little clearer. That's a 7d right there. There we go. 5 times 7d plus 1. And we're looking for 7d plus 1, and we got them. So that means the fact, now we're going to use the distributive property to remove these. So we're going to have 9d plus 5. That's our one pair. And 7d plus 1 times 7d plus 1. There's that term. So now let's see what we have on this on the next one. We're gonna multiply 11 and 100 and 200 and 20 together, right? So what does that come out to? 11, is that 220? So when we multiply 11 times 20, we get 220. And we got it, whatever we're going to use for 220 here, so I'm going to say that 11, it's all positive, times 20 is equal to 220. So we're going to factor 220 until we come up with a 49. So if we start right away, we can take a 0, a 2 out of here. So we're going to take the 2, that's right here, 2, and what's left is 110. You can take another 2 out, is 55. So if I take a 2 out, I got a 55. I'm getting close. I've got a 49 I'm looking for. Out of 55, there's no more 2s. I can get a 5 out. And 11. Oh, that's interesting. 5 and 11. So let's see, 5 and 11. I have 11, 4 and times 4 times 5 is 20, and 11 is 49. It's not there. We're still not there yet. Give me a second here. So I've been looking at this, and it looks to me, as we've gone down, I can see now that the factors are right there. We've got the factors. Because if we can take 4, no, let's see. I just had it. Hold on a second. Okay, I'm sorry. I lost it. Now I'm back with it. So I can take the 11 right here. I can take the 11 times these two, the 4. 4 times 11 is equal to 44. And the 5, so the 5 and 44 will give us the number, the 220 we're looking for. 5, 10, 4, 11, 44, and 5 is going to give us what we're looking for there. But the 5 is 5 and 44 plus 5 is going to give us the 49. Okay, so I'm going to erase that because that's kind of scribbly. Anyways, so it's 11 times 2 is 44, plus 5 is 49. So our numbers are 5 and 49. I'm sorry that was as difficult as it was. I mentioned it was going to be difficult. And I'm doing these with you. As I'm going through them, I'm solving the problems firsthand. So it's quite interesting. So we're going to write that down. We're going to factor this out now. So we're going to say right here, we're going to say 11. Get rid of the eraser. And we're going to say 11k squared plus 11k plus No, excuse me. I back up. See, it's complicated. Not 11k. It is 44k. 44k plus 5k plus 20. Sorry, this seems to be so difficult, but they are very interestingly difficult. So now we have these two here. These two are grouping and these two are grouping. So we have 11k squared plus 44k. Well, there's an 11 and 44, and we know that. It's going to be a 4. So we're going to be able to take out out of the 11, we're going to take an 11 out of both of these and the k out of both of them. So we're going to have 11k times k plus 4. Okay, and then we're going to say plus. Now what are we going to take out here? We can take a 5 out of both of these. So that's going to be a 5 times k plus 4. Because we took a 5 out of the 20, we have a 4. So now that we've done that, we can take the 11k plus 5 right here, plus 5, and times k plus 4. K plus 4. Okay, and there's our solution, 11k plus 5, and it ends up being k plus 4. Sorry for that. Like I said, I'm doing these with you, so it's interesting. Go on to the next slide now. Okay, here's the second slide in our example 3. It was 3b, checking your understanding. I want you to solve this trinomial by grouping. Go ahead and try it on your own and see what you come up with, and when you get back, we'll do them together. Okay, I assume that you've stopped and tried, and you've all succeeded. And let's go ahead and do it and see where we end up with this. So when I look at this, I see right off the bat that I need I have a 4 as an A term and a negative 70, but I don't need the negative 70. All I need is the 70. And if I say 70 times 4 is equal to 280. So we need factors of 280 that are going to give us a positive 33. But before I go digging through the factors, remember, and this is a catcher, this is going to get more people wrong on their tests. You have to look at these signs. You always have to look at the signs. And when there's a negative C term, in order to get a negative C term, you have to have a positive and a negative because they multiply. Your factors, they multiply. And if you have a positive and a positive, you'll get a positive C term, or a negative and negative, you'll get a negative C term. A positive C term. You need a negative C term because it has to be a negative and a positive. And also, once you decide that you need a negative and a positive, you have to look at your B term. And you have to look at that plus sign or negative sign right there. This one right here. Is it plus or negative? And if it's plus, the larger term is the positive term for your C term. And the smaller term is going to be your negative term. If this were a negative, your negative term would have been the larger term, and your smaller term would have been the positive term. And it's just obvious because in order to add two numbers together to get the positive 33, you have to have a larger, say, some number to subtract a smaller number from it. If you had a larger negative, you'd never be able to get above 0. So, okay, so now let's factor this out. So then I do the typical factoring. I factor out the primes. So I do that, and I get 140, and I get another 2 and a 70, and out of this I get a 2 and a 35, and out of the 35 I get a 5 and I get a 7. Well, then I look at this and I figure, well, how am I going to get a 33? So I start, and by the way, when I come up with two terms, the small one needs to be the negative term. So that means I'm going to have a term larger than 33 and a term smaller than 33. maybe a lot smaller than 33. So let's see. So if I say 2 times 2 times 2 is 8. 8, that's in the 7 and 5 is 35. 8, 35? No, that's not going to get us 33. So how about 2 times 2 times 2? 8 times 5 is 40. Oh, there it is. 40. That's the sum of all of these out here. The sum of all of these 2's and this 1, 5 and the 7. So 40 minus, there's the minus. So positive 40 minus 7 will give us 33. These are not easy to come up with. It takes some mental gymnastics, let's put it that way. And so now that we have that, we have our terms. So now I'm going to rewrite this. I'm going to say 4y squared plus what? Plus 40. The plus is our 40 term, the large term. 40y. Now I have a minus term. Minus 7y. And then finally I have a negative 70. So now I'm going to group this one together and these two together and these two together. So on this side, on the left side, I have a 4y squared. I have a y, so I can get a y out. I have a 4. Well, I can take a 4y out of both of these terms. So 4y times a y plus 10. 40 divided by 4, we're going to get the 10. Okay, and it's going to be, that's closed, okay? And then we're going to, I'll say plus right here. Now I have to take out a y, I can't get a y. I have to take out a 7, I can get out a 7. I have two negatives, I can get out a negative 7. So minus 7 times y plus 10. I took a negative 7 out of negative 70 and got a plus 10. And as soon as I did that, I have y plus 10 and y plus 10. And of course, as you're doing these, as you're solving this, you look and say, oh, I need, once you get here, you say, I need a y plus 10. So you look at your extra term to see, is there a y10 sitting in there somewhere? And voila, you say, oh, there it is. So now I have to take the 4y minus 7 right here. And then I have to take the y and the plus 10. So it's y and plus 10. And that's our answer. Okay, example 4. Finding the dimensions of a rectangular prism. It says this is a geometry problem. The volume, length, width, and height, length times width times height, of a rectangular prism at the right, this is the picture of it, is 80x cubed plus 224x squared plus 60x. Factor to find the possible expressions for the length, width, and height. So that means that you could probably come up with a number of different values, but you're gonna when we solve this problem, we're gonna come up with one set, and that's good enough. It's not gonna hurt how we come up with it, as long as it gives us the correct answer in the volume. But there are numerous answers that are all correct. So it says, in order to do this, we're going to factor 80x cubed, 224x squared, and 60x. So the first thing we're going to do, as they taught us to do, is factor completely, right? So we're going to remove any common monomials that are in here. And we see there's an x in every one, so we know we can get an x. Here it is. And we see that it's 80, it's at least a 2, a minimum of a 2. But we can get, if we go through this, if we take a 4, we'll get a 20 here. If we take a 4 out of this 220, we're going to get I guess that's 56 right here. And then if we take a 4 out of 60, we're going to get 15. So that's what we did. We took a 4x out. We factored a 4x out, and we got a 20x squared plus 56x plus 15. So now we're going to do our typical trinomial grouping factoring a trinomial by grouping. So we're going to multiply the inner and the outer, the A and the C, and we're going to get 300. And then we're going to start looking for factors of 300 that'll give us 56. And when we do that, we start with the 5. We'll get 5 times 60. Well, 5 plus 60 is 65. And you see the pattern. 10 times 30 is 300. 10 plus 30 is 40. Again, we're looking for 56. Eventually, we get down here to 6 times 50, and we get 6 plus 50 is 56. We found our answer. So now we're going to go on to the next slide to finish it. Okay, so now, example 4, finding the dimensions of this rectangular prism. Now that we have that factored and we have our 4 terms, we're going to group them. And the grouping is going to go, as you see it here, we're going to pull out of, we're going to pull from these. Here's our 2, and here's our 2. But since we've got this extra 4x, we've got an extra bracket in here to try to keep things separate. We want to keep this 4x on the outside looking in, so to speak. So now from the 20x squared plus 50x, we're going to take out a 10x because there's an x in both and 10 in both. Okay, but there's not a 20 in both, so we can't. But the 10 is the biggest number we can take out. That's common. So we take out a 10x and it leaves us with 2x plus 5. 10x from 20x squared is 2x, and 10x from 50x is 5. And then we go to the next one, and we're looking for 2x plus 5, and we look in here, and look at that. We can take out what? We can take out a 3 and get a 2x. And if we take a 3 out of here, we get a plus 5. And that's what we did. We took out the 3 and got 2x plus 5. And here's that term we're looking for. So now that we have that, we can now factor this, right? So we can take the 10x and the plus 3, the 10x and the plus 3, and make our first term out of it, 10x plus 3. And we already have our 2x plus 5, 2x plus 5, and 10x plus 3, right? You see them, right? And we had to have the 4x on the outside. And that's our answer, right here looking at us. Good job, everyone. Okay, example 4, check your understanding. What they want you to do, it was what we just basically did previously, is they want you to factor this equation that's here in this prism here, or this rectangular prism right here, factor that, and then see if we can come up with a length, a width, and a height. We're going to get 3 terms. We got it last time, 3 terms. You'll see it again. It'll pop out at you. So go ahead and give it a try. And then when you get back, there's another slide after this one, if I'm not mistaken, for an identical example. We'll see how that one goes too. So go ahead and pause the video, and then we'll try these. Okay, now that you're back, let's give it a try. Let's see. So the first thing I'm going to do is I'm going to write the equation because it's not even written here. So I'm going to say 6g cubed plus 20g squared plus 16g. So you see right away that there's a g everywhere in here. And these are all even, so there's a minimum of a 2, right? There's no 4, there's no 6. So I'm going to say 2 can come out because you got this 20 here, okay? So let's take out a 2 and a g. A 2g is going to come out. And then that's going to be leaving us a 3g squared, and a plus, we took a 2 out, plus 10g, and a plus, we took a 2 out, 8. So here's our trinomial to factor. And let's do it the way we just did it, right? So we're going to go ahead and break this. We're going to multiply these 2 terms. We're going to get a 24. A times C is equal to 3 times 8 is 24, right? So we have 24. We want the factors of 24. So we have a 2, right, and a 12, and a 2, and a 6, and a 2, and a 3. And we're looking for a 10 in the center here. So what can we get a 10 out of this? So to get a 10, and this is a positive, and this is a positive. So they're both terms are going to be positive. We're adding, and when we add them together, they're going to have to both be 10. Because what they're going to have to equal to is 10. So we're going to have to get something like a 6 and a 4 to get a 10. And guess what? We've got a 6, and here we have a 4. So it's exactly what we have. We have a 6 times 4 are our terms. And 6 plus 4 is equal to 10. So now we can write 2g, okay, I'm just going to do the bracket here, and it's going to be 3g squared plus 6g, plus 4g plus 8. Okay, now we're going to factor right here. These two and these two, we're going to factor them. So 2g times, we're going to pull, what can we get out of here? We can get a 3 for sure and a g. So we can get a 3g, and that leaves us a g inside here, and a plus, we took a 3g out, 1. Oh, no, I take that back, sorry, 2. Let me erase it and 2. Okay, and then plus, what can we take? We can take a 2, only a 2. We can get a 4. We can take a 4 out, and we get a g plus 2. Oh, look at g plus 2, g plus 2. So we have a 3g and a 4. So we're going to have 2g times 3g plus 4. Sorry, I was looking for it. And a 4 oh, I'm sorry. That was my mistake. I had a brain freeze here. Sorry about that. Shouldn't have to do that. Not the 4. It's just the 2g, the g plus 2. And I have the, g plus 2. So the sides of this can be 2g. We don't know anything more about it than this. It can be, the length can be 2g. It's times and times, right? Times the height, which is going to be 3g plus 4, times g plus 2. So there's that one. Now let's see if we go on and get the next one. Okay, find the expression for the possible dimensions of each rectangular prism. Well, each, because we already did one. Here's our numbers. It's exactly the same thing. They just wanted you to do twice. So go ahead and do it. When you come back, you should be able to get it yourself on this one. We just did one. When you get back, we'll do it together. Okay, let's give it a shot. I'm going to write the equation, the trinomial. The trinomial says 3m cubed plus, because it has to be cubed, right? Because it is a cube. You see, it's a cube. Plus 10m squared plus, and they're all positive, 3m. So our numbers are going to be positive. We don't have to worry about that negative being larger and smaller, right? As you heard me talk about. So right off the bat, there's an m that's going to get filtered out of here. And there's also what? Nope, can't get anything else because we have the 10 won't let us get anything but a 5 and a 2. And we only have a 3. So given that, we're going to take out a single m. M times 3m squared plus 10m plus, plus 3. Sorry, I was looking in the wrong spot. So there you have that. That's our new trinomial. Now we're going to factor this. We're going to take our 3 and our 3, and that's our AC, is equal to 3 times 3 is 9. Our factors of 9 are 1 and 9, of course, or 3 and 3. So what can we come up with? I'm going to say 1 and 9 are our factors because we're looking for a 10. So doing it, factoring primes didn't help us out. We just took the first set of factors here. Okay, and doing that, I see that it doesn't matter which one we use. It's just a 1 and a 9 because they're both positive. So I'm going to rewrite it. M 3m squared plus 9m plus 1m plus 3. Now we're going to group these two and these two. And out of these, there's a 9m and an m. I can get a 3m out of both of these terms. So I'm going to say 3m. I'll bring down the parens and put this m there too. 3m times, I'm taking out a 3m, so I have a m remaining. It's plus. I took out a 3, so I'm going to have a plus 3 because I'm taking out a 3m. So it's 9m divided, taking out the 3, taking out the m, excuse me. Oh, I'm in the wrong spot. 3m, I have to take out the 3m right here, and it leaves us with m plus 3. And now we have to do a plus on this. We can get out a m and a 3. There's nothing we can take out of this. It's just a 1. So a 1, we can take out that 1, and that's times m plus 3. M plus 3. So when we factor this out, we're going to get an m over here, and we have a 3m plus 1, the 1's right here, plus 1 times m plus 3. And that's our answer. A length could be m, L can be equal to m, and the width can be equal to 3m plus 1, and the height can be equal to m plus 3. That could be the answers to this problem. Okay. Excuse for any, please for any tongue-tied or when I have these brain stumbles, but hopefully we get through them and survive it. Okay, and so factoring polynomials, this is a final note. It's a summary, just to keep in mind as you're doing this factoring. First, factor out the greatest common factor. That's what we were trying to take out when we did the complete factoring, right? We take out the one term ahead of time. Then, if the polynomial has 2 terms or 3 terms, look for the difference of 2 squares, a product of 2 squares, or a pair of binomial factors. So go back, look at all. That's what you need to know. Is it a difference of squares? Okay, is it a product of 2 squares, or are there a pair of binomial factors? That's what we can do the grouping, right? So that's what they want to know, that when we're doing the factoring. Then, if there are 4 or more terms, group the terms and factor to find common binomial factoring. We just did that in the previous slides, where we grouped them and then factored out common factors out of the smaller group. And as a final check, make sure that there are no common factors other than 1. So as you're coming down looking for common factors, there's still not one hanging around. You can get them all, is what they want you to do. Okay?